In this quick lesson, I'll show you 4 more examples on how to test for divergence using the limit test with infinite series. This is part 2. To do this, you'll need to know the limit test, which is also known as the divergence test, and it states that if the limit as n approaches infinity for the function representing our series does not exist, or if the limit as n approaches infinity does not equal to 0, then the series, which is defined as the sum for a sub n, is divergent. The test, however, is inconclusive when the limit is 0. The question reads, what does the divergence test tell you about the convergence or divergence of the following series? We'll start with a harmonic series, and what this looks like, if we were to write out the terms, is we would start at 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 and so on. And notice that the middle term is always the average of the one before it and the one after it. And that's by definition what harmonic series is. So what we will do here is take the limit as n approaches infinity for our sequence function 1 over n. And if we take the limit of 1 over n, we'll end up with 1 over a very large number, and that eventually goes to 0. Because we get a result of 0, no conclusion can be made. Let's move on to the next one. Here we have the sum of 6 to the power of 1 over n. If I substitute a very large number into n, we'll end up with 1 over a very large number, which eventually goes to 0. 6 to the power of 0 is equal to 1. Now, since 1 does not equal to 0, then this diverges. In our next example, we have a polynomial divided by a polynomial. The highest degree here is n to the power of 5. So I'll multiply the top and the bottom by 1 over n to the power of 5. And the reason why I'm doing that is because if I take the limit now, I'll end up with infinity over infinity, and that won't work. So I need to algebraically manipulate it. Multiplying each term by 1 over n to the power of 5 gives me 7 minus 3 n to the power of 2 over n to the power of 5 plus 1 over n to the power of 5. And similarly at the bottom, 3 plus 4 n to the power of 4 n to the power of 5 plus n to the power of 3 n to the power of 5. This becomes 1 over n to the power of 2. The n's in the numerator go away, leaving us with only 1 at the bottom. Those go away, 3 at the bottom, and 1 over n to the power of 5. Taking the limit of this term will give us 3 over a very large number. That eventually goes to 0. This goes to 0, this goes to 0, and this goes to 0 for the exact same reason. We're left with 7 over 3. Now, since 7 over 3 does not equal to 0, this diverges. Finally, in our last example, we have the sum of 8 times sine, and the angle is 1 over n. Substituting a large number into n gives us 1 over a very large number, and that's equal to 0. Sine at an angle of 0, if you remember the wave, always starts at 0 and 0. So 8 times 0 is equal to 0, and we can not come up with a conclusion. And so there you have it. 4 more examples on how to test for divergence using the limit test.